Unit 2, Lesson 6, Half Interested or More Interesting. In our Jumpstart, we looked at a problem that involves a geometric progression. Specifically, it's about medicines given to a dog. Suppose a dose of 60 milligrams of anti-parasite medicine is given to a dog, and the medicine breaks down such that 20% of the medicine becomes ineffective every hour. How much of the 60 milligram dose is still active in the dog's bloodstream after 3 hours, after 4.2 hours, and after n hours? Now, we actually didn't solve this. What we did is we did a notice and wonder. What we notice might be things like these two tables are exactly the same. What we might notice is that 20% and 60 milligrams are present here, and then 20% keeps repeating itself. What we might wonder is, for example, how are we going to go 4.25 hours? We might wonder why in the equation number 3, why are we using 0.8 instead of 0.2? Okay, so let's move on to our main topic today. Again, we're back to the twins, Carlos and Clarita. And they've run a summer business every year for the past 5 years. So that means 5 years ago, they first started earning money. Their first business, lemonade stand, earned a small profit. Their father insisted they deposit that profit in a savings account at the local bank. When the family moved a few months later, the twins decided to leave the money in the bank. It has been earning 5% interest annually. That means every year, annual. Carlos was reminded of the money when he found the annual bank statement they had received in the mail. He says, "Remember how Dad said we could withdraw the money from the bank when we are 20 years old? So they must be 15 years old right now. 5 years ago they started it when they were 10, and then they'll get the money at 20. Carlos said to Clarita, "We have $382.88 in the account. Now, I wonder how much that will be 5 years from now." So that's the story. Now, Carlos calculates the value of the account 1 year at a time. He has just finished calculating the value of the account for the first 5 years. Describe how he can find next year's balance and record that value in the table. Well, there's two different ways he could do this. One thing he could do is he could take 5% as a decimal, multiply it times 382.88, and that will give him his interest for that year. In other words, I'm trying to figure out how he got to 402.02. So 0.05 times 382.88 is $19.14 if we round it. So he made a jump of 1914. So he had to take 382.88 and add that number, 1914, onto it. So we could get the next number here by finding out what is 5% of 465.39, and that number is $23.27. And you can add it on to the existing amount of 465.39, and you will get 488.66. That's one way he could do it. So jump 23.27. But another way he could do it is he could take that 465 and 39, and he could multiply it by 1.05. Now, what that does for him is it automatically includes the 465 as part of the total, and then figures out 5% of that. So you can try this on your calculator. This will come out to this. Clarita thinks Carlos is silly, calculating the value of an account 1 year at a time, and says he could have written the formula for the nth year and then evaluated his formula when n equals 5. Write Clarita's formula for the nth year and use it to find the account balance at the end of year 5. So just imagine this is geometric. We need to know two things. We need to know, first of all, where does it start? So it starts at 382.88. How do we move to the next number? We multiply by 1.05, and you do that n times. Now, if she evaluates f of 5, that means she puts into the calculator 382.88 times 1.05 to the power of 5. And guess what? You get that value as well, 488.66. Now, Carlos was surprised, number 3, that Clarita's formula gave the same account balance as his year-by-year strategy. And so how could we convince him that it's going to work? Well, if you take 382.88 and you multiply that by 1.05, but then you do that again, and, oops, that's a multiply. And again, how many times do we have to do this? Times 1.05 times, oops, 1.05. Well, if you do it 5 times, back to back to back, you're going to get the same thing. Because that's the same as taking 1.05 to the power of 5. Now, Carlos says, I can't remember how much money we earned that summer. I wonder if we can figure out how much we deposited in the account 5 years ago, knowing the account balance now. So Carlos uses his strategy to figure out how to go backward. Now, think about it. If you're multiplying by 1.05 as you go down, then to go back up, all you have to do is divide by 1.05. So sure enough, if you take 382.88, you divide it by 1.05, you're going to get this 364.65 number. Now, you don't want to remove the decimals from the calculator or round it off. Just take that and divide it by 1.05 and write down the rounded off version to the nearest penny. You'll get 347.28. You probably want to check this with me. Divide that by 1.05. You'll get 330.75. Divide that by 1.05. You'll get 314, oops, no decimal there. 314, actually rounds to 315, even. 315, and divide by 1.05 one more time, and basically it rounds to 300. So explain what you think Carlos is doing to find his table values 1 year at a time. It's easy. Dividing by 1.05. Clarita evaluated her formula for n equals -5. So in other words, she's going to go into the past with the variable. F of -5 is going to be this 382.88 times 1.05 to the negative 5. And sure enough, you're going to get that number if you round it. Now, Clarita doesn't think leaving the money in the bank for another 5 years is such a great idea. She says, we'll have some startup costs, and this will pay for them without having to withdraw money from our other accounts. And Carlos remarks, but we'll be withdrawing our money halfway through the year. Don't you think we'll lose out on this year's interest? No, she says, they'll pay us half-year portion of our interest. Oh, but how much will that be? Asked Carlos. Calculate the account balance and how much interest you think Carlos and Clarita should be paid if they withdraw their money a half year from now. Remember, they currently have $382.88 in the account and earn 5% annual interest. So if we take that 1.05 and we multiply it, we take it to the power of 1/2, or if you like as a decimal, 0.05, you're going to get 1.00244. Well, we can just take, to get the answer directly, 382.88 and multiply it by 1.05 to the 1/2 power. And that should turn out to be 392.33. If I want to find the amount of interest, I can just subtract 392.33 minus 382.88, $9.45 interest. Now, Clarita used the strategy. She substituted 1/2 for n in the formula and recorded this as the account balance. But Carlos has some questions. Answer each of Carlos's questions. What numerical amount do we multiply when we use 1.05 to the 1/2? Well, let's see. I already wrote that down. 1.05 to the 1/2 power is, apparently I wrote that down incorrectly before. That was going to be 1.024, let's say 7. I have to round it. What happens, next question, what happens if we multiply by 1.05 to the 1/2 power and then multiply the result again by 1.05? Well, think about it. If you take this to the 1/2 power times this to the 1/2 power and you add the exponents together, you're just going to get the 1 power. So it's really just 1.05. You take the two 6-month interests, you combine them, you get the yearly interest. So what that suggests is that since I'm doing it twice to get 1.05, then that 1.05 to the 1/2 power is really just the square root of 1.05. So as Carlos is reflecting on this example, Clarita notices the date on the bank statement that started this whole conversation. This bank statement is 3 months old, she exclaims. That means the bank will owe us 3/4 of a year's interest. So how much interest will the bank owe us then? Well, that would be our value of 382.88 times 1.05 to the 3/4 power. And that will be let's see. Oops, I forgot the 1.05. 382.88 times 1.05 to the 3/4 power. 397.15. Not bad. So their original amount way back when was $300, and in 6 years it will have grown, almost 6 years, it will have grown to almost $400. Not bad. Find as many ways as you can to answer Carlos's question. How much will their account be worth in 3/4 of a year if it earns 5% annually and is currently worth $382.88? Well, I think I just answered that question right there. Carlos now knows that he can calculate the amount of interest earned on an account in smaller increments than one full year. He would like to determine how much money is in an account each month that earns 5% annually with an initial deposit of $300. He starts by considering the amount in the account each month during the first year. He knows that by the end of the year, the account balance should be $315 since it increases 5% during the year. Well, just as an example, so how am I going to calculate this box right here is going to be 300 times 1.05 to the 1/12 power. So just whatever it says under the deposit row, that's the power you're going to put. So the values become 301.22, 302.45. It's getting really boring if I write all this out. So let me just go to year or month 7, 308.66. And you know how it's going to end. It ends at 315. So you can go ahead and fill in the rest of the table by doing that fraction. But what number did you multiply the account by each month to get the next month's balance? Okay, so if you view it as a geometric sequence, then all you have to do is that 1.05 to the 1/12 power, and that is 1.004074 if I go ahead and finally round it off. Or about 1.004. Ought to give you some pretty good accuracy there. So, wow, that's a lot, isn't it? We'll see you next time.